Everyone, how are you? I hope you all are fine. So in this video we will discuss about resultant of any two vector. Okay, so let's see resultant of two vectors. Two vectors. Okay. Let's see the resultant of two vector. First we draw vector. Then this one is A vector and this one is B vector. Uh, and we had to find a resultant, so we have to shift parallel of any vector we can also shift parallel B vector, or you can also shift parallel A vector. Okay, we shift parallel, this one is B vector. Okay, or you can also draw like this, that this one is A vector, this one is B vector, and you can also put parallel A vector here, and also say this one is A vector. And now this gives resultant. Okay, because first of all we have to draw first vector and draw second vector on the head of first vector, and from tail of first vector to head of last vector, join the tail of first vector to head of the last vector. It gives resultant. Okay, you can also draw like this, and you can also draw like this. Okay, and now you know that first we draw one vector, draw second vector on the head of first vector, this one is second vector, and from tail of first vector to head of last vector, join the tail of last vector, join the tail of first vector uh, to head of last vector. It gives what? Resultant. Okay, this one is R vector is equal to what? A vector plus B vector. Okay, resultant means simple meaning is a sum. Okay, and now we also draw perpendicular. Now we draw perpendicular. Okay, this one is draw perpendicular forms. Suppose that this one is A. Okay, we draw perpendicular. This one is B and this one is C. Okay, this. Oh, sorry. Draw perpendicular. Okay, so this angle is 90. A, B, and this one is C. Okay, draw perpendicular from C on this one is OB. Okay, draw perpendicular C from C on OB. Okay, and now A, B, C, like this one is D. Okay, now let OA vector is equal to A vector is equal to A vector. Like here you can see that OA vector is equal to A vector. Okay, and OD vector is equal to B vector, and OD vector is equal to B vector. Okay, and let this angle is theta. Okay, theta. Sorry, not theta. Theta is equal to angle between angle between A vector and B vector, A vector and B vector. Here you can see that theta is the angle between A vector and B vector. Okay, and you can also say that theta is the angle between OA vector and OD vector. Okay, and now we draw perpendicular. Draw perpendicular from C on OB. Okay, draw perpendicular C from OB. Clear? So, and now from triangle from triangle here you can see that this one is a triangle. From triangle OB, from triangle OBC, from triangle OBC, from triangle OBC. Here you can see that this one is right angle triangle because this angle is 90. Okay, this one is right angle triangle. So by Pythagoras theorem, h square plus h square. What is Pythagoras theorem? H square is equal to b square plus b square. This is Pythagoras theorem. Okay. By this, here you can write OC square is equal to, this one is base, OB is the base of triangle OBC. So you can write here OB square plus, this one is the perpendicular, BC is the perpendicular of this triangle OBC. Okay, so you can write here plus BC square by Pythagoras theorem. Pythagoras theorem. H square plus h square is equal to b square plus p square. Okay. OC, this one is OC is a resultant. Okay, a vector. So here you can write R square is equal to OB this one is OB. Okay, So you can write that OA plus AB. You can write OA plus AB is equal to OB. Yes, of course. So write down here OA plus AB square. Okay. Why? Because here you can see that OA plus OB is equal to, sorry, OA plus AB is equal to OB. Okay. And now here is BC plus BC square. Now R is equal to root under OA plus AB square plus BC square. This one is the equation first. Okay. So this is our first equation. And now from triangle ABC, from triangle ABC, from triangle, and now from triangle ABC, from triangle ABC, we know that sin theta is equal to perpendicular by height. Sin theta is equal to, this one is a BC, this one is perpendicular, okay, and this one is AC is the hypotenuse of triangle ABC. Okay, we know that sin theta is equal to perpendicular by hypotenuse. Perpendicular is equal to BC by BC, and hypotenuse is AC. Okay. So here you can write that BC by AC, okay, is equal to BC by B, because AC is, this one is B vector. Okay. AC is B because we this one is B vector and we shift parallel. Okay, so AC is equal to B. Okay, so you can write here that by B. Okay, now BC is equal to B sin theta. Sin theta. BC is equal to what? B sin theta. And now we know one more formula, one more thing, that cos theta is equal to base by hypotenuse. By this, cos theta is equal to base by hypotenuse. AB is the base of this triangle, and AC is the hypotenuse of triangle ABC. Okay, so here you can write that cos theta is equal to base by base by hypotenuse. So you can write AB is the base and AC is the hypotenuse, and you can also write like this: AC is equal to B. Okay. Now AB is equal to B cos theta. B cos theta. AB is equal to B cos theta. And now from equation first, this one is our first equation, that R is equal to root under OB plus AB square plus BC square. So this one is our first equation, that this one is our first equation. Okay. R is equal to root under OA plus AB. OA, here you can see that OA is equal to A. OA is equal to A. So here you can write that the place of OA is equal to A square plus AB. AB, here you find that AB is equal to B cos theta. Okay. So AB is equal to B cos theta square. Okay. Or you can also square. Okay. And now in the place of BC, we can write B sin theta. Here you can find that BC is equal to B sin theta. Okay. So let's put on the place of BC is equal to plus B sin theta plus B sin theta square. Okay. Square. Okay. And now let's solve for the root under A square plus, you can also write B cos theta square plus B sin theta square. Now let's solve for the is equal to root and under this one is a sorry, here is a formula that A square plus B square. That to do this, here is the formula of A square plus B square. Okay. The formula A square plus B square. This is the formula of A plus B whole square. Okay, A square plus B square theta. This is the formula of A plus B whole square. A square plus B square plus 2AB cos theta. Okay. And last one is B square sin theta. Sin theta. Sin square theta is sin square theta, sorry. Sin square theta. Okay. Sorry. This one is the formula of a plus b whole square. Okay, a square plus b square plus 2ab. Okay, so here can this one is a and this one is b. So a square plus b square plus 2ab. Okay, and now let's solve further. That r is equal to a square plus let common b square from here and here. Okay, b square is, so if we if we common the b square, then here is cos square theta plus here sin square theta. Okay, and plus 2ab cos theta. Now, so since we know that sin square theta plus cos square theta is equal to what? 1. Okay, we know that sin square theta plus cos square theta is equal to 1. Okay, now here you can write that r is equal to root under a square plus b square, and we know that sin cos square theta plus sin square theta is equal to 1. Okay, so here is 1 plus this one is 1 and plus 2ab cos theta. Okay, now this one is the formula of any two vector, that r is equal to root under a square plus b square plus 2ab cos theta. This one is the formula. Okay, so I hope you understand that the resultant of any two vector, that first we shift parallel. Okay, after that first of all we shift parallel of any vector. Then also shift a vector or b vector, both. Okay, first we shift parallel and then we draw perpendicular. You can see that and then we draw perpendicular from C on OB and solve it. This one is the derivation of this one is the derivation. Sorry. This one is the resultant of any two vector. Okay, that is r is equal to root under a square plus b square plus 2ab cos theta. Okay, so I hope you understand that resultant of any two vector. Okay, so that's all for today. Thank you. Have a nice day.